Happy Thanksgiving.
A good meal is one of life's pleasures, but it's much more than that. Food provides your body with energy to move, to grow, to think. The digestive system is responsible for breaking food down and then absorbing it into your body.
Thought of this food is great.
The digestive system works automatically.
When you think of peanuts, you don't normally think of energy. Do you think there's much energy in this peanut?
No. Yeah, maybe.
It's just sitting there. Doesn't look like it has much energy in it. Should we try and release the energy?
Yeah.
Okay.
Some foods, like peanuts, have lots of energy, fuel for your body.
Let's see what happens if we try and burn it.
A burning peanut quickly releases energy.
It's doing something, I think.
Oh, it seems like it's smoking.
Inside your body, a much slower release of food energy takes
Still
place
burning,
within every living
It's a
cell.
lot of energy.
Before we can use food energy, food must be broken down into simpler substances. That's the job of our digestive system, which is basically one long tube that begins at the mouth. The main parts of the digestive system include the mouth, where we taste, chew, and swallow food. 3 pairs of salivary glands that moisten food and add digestive chemicals. The esophagus, a tube that passes food from the mouth to the stomach, which is a muscular sac where more digestion takes place. The pancreas and liver produce digestive chemicals that are added in the small intestine. The small intestine is where most digestion takes place and where nutrients are absorbed into the bloodstream. The large intestine absorbs liquids and vitamins, leaving behind solid waste, which is eliminated through the anus. It takes about 24 hours for food to travel through the entire length of the digestive system.
When we swallow, that starts a series of contractions that push the food through our digestive tube. So let's let this tube represent our digestive system, and we'll let this be a bite of food, some kind of food. Okay, I'll try and get it going.
Special muscles throughout the digestive system squeeze together in a traveling wave that pushes food in front of it. This automatic movement is called peristalsis. Peristalsis moves food through the entire digestive system in much the same way that fingers can move a piece of clay by squeezing a soft tube.
Here comes our food.
Thanks to peristalsis, food moves through the digestive system even when you're upside down. The digestive system starts working as soon as you put food in your mouth. Once food is in your mouth, your tongue goes to work. The tongue is almost solid muscle. It positions food next to the teeth for effective chewing. The tongue also contains special nerves, taste buds, that detect flavors in the food we eat. Teeth chop and grind food and mix it with saliva, fluid made by the salivary glands. Saliva contains special chemicals called enzymes that help break down large food molecules into smaller ones. When you are finished chewing, the tongue pushes your food into the esophagus, the passageway to the stomach. Food doesn't just drop into the stomach. Peristalsis pushes it along.
So now we've chewed, we've put saliva into the food and mixed it, and we've swallowed, and the food is now in this bag, the stomach. Let's take it out of there. The stomach is a muscular bag, and the food inside is churned. Can you ever feel that churning?
Yeah.
Yeah. After you've eaten? Yeah? Rumbles?
The stomach contains powerful acids and enzymes that help us digest food. The stomach doesn't digest itself because it is protected by a special mucus lining that resists acids. Folds in the stomach allow it to expand after a big meal.
What I'd like to do is try to investigate how our stomachs actually carry out digestion. And to do that, I want to build two stomachs and do a comparison. We have two soccer balls here. They're the same size.
An experiment can
Each
demonstrate the power of digestive acids and enzymes. Two soccer balls substitute for stomachs.
And we have two hamburgers, plain hamburgers, that we can use as meals. And we have two different solutions. In one case, we have pure water, and another solution which contains stomach acids, digestive enzymes, similar to what you'd find in your own stomach, and water. Make sure that doesn't spill. All the way in there. Thank you. Good. Good. Excellent.
One soccer ball holds a hamburger in plain water. The other ball has a hamburger and water, but also contains digestive acids and enzymes, as your stomach does.
We need something to do that would mimic how the stomach churns the food. What could we do with soccer balls that would be good to churn the food?
Kick them.
A little soccer, maybe.
Coming back at you, Matt.
So, now that we've kicked these things around and we've modeled the way that our stomachs work on foods to carry out digestion, let's see what's inside. Now let's see what's left without the stomach acids and enzymes, with just water as a solution. Sheila?
In the ball with only water, the hamburger meat has been broken apart by the soccer game, but it hasn't been dissolved.
Good work. Matt,
The
could you
contents of the other
save
ball
this?
resemble what you might find in your
Now let's see
stomach.
what we have in the other
Digestive
stomach.
juices and enzymes have dissolved the hamburger meat into a liquid with the consistency of a milkshake.
Okay. Good.
Food in the stomach is mashed and mixed with digestive chemicals for between 2 to 6 hours. It can be hard to stop eating a good meal, but your stomach only holds so much.
Whew, I'm full.
How much food fits into the average sixth grader's stomach?
This shows how much your stomach will hold. Just about 3 pints.
Food stays in the stomach until there is room for it further along the digestive system. Food leaves the stomach little by little as it is squeezed into the small intestine.
So when the food is finished in the stomach, it gets passed on to the next piece of our system, called our small intestine. This tube is over 20 feet long in our bodies. Let's take a look at it. This is a very, very long, coiled, relatively small tube that food seeps through. Do you want to try this one on? Pass it around. So this is where we've got more digestive enzymes, and slowly but surely the food is being absorbed into the bloodstream. Yeah, that looks great.
The small intestine is where most digestion takes place. It's a very slow process, but in this greatly speeded up view, food is visible as it moves through the small intestine. Additional digestive juices are produced in the walls of the small intestine, and still more juices are sent from the liver and pancreas. These digestive juices complete the breakdown of food into molecules small enough to be used by the body.
I've brought in a hose which is cut to just about the length of your small intestine. Let's unroll it and take a look at it. Caitlin, could you hold one end and, let's roll it right out in a straight line here. Matt, good.
The small intestine may be as long as 6 meters. Why do we need so much? The length of the small intestine gives the body plenty of opportunity to absorb nutrients from food.
And Joseph, good work. In addition to your small intestine being 20 feet long, it has folds and bumps on the folds to increase the surface area.
Throughout the folds inside the small intestine are millions of tiny finger-like bumps and projections called villi. Villi greatly increase the area of contact between digested food and your small intestine. With wire and drawings, you can get an idea of how villi expand the contact area between the small intestine and food. The plain circle represents a slice of intestine without villi. The squiggles in the other drawing represent a slice of intestine with villi inside.
JP, could you and Shiloh show us what you've come up with? We'll separate.
One red wire measures the length of the plain circle without villi. The other red wire measures the length of the villi-like squiggles on the other drawing. Even though both drawings take up about the same space on a piece of paper, the wire from the villi drawing is much longer.
This is just a slice across a tube.
Villi in your body are not flat like a drawing, but three-dimensional.
I'm going to help by smoothing.
Providing even more contact
All
with
these
food.
folds and villi are now straightening out.
As digested food slowly moves the length of the small intestine, food molecules become small enough to seep through the thin walls of the villi. Nutrients from the food you ate hours ago are finally absorbed into the body. Villi contain a network of tiny blood vessels, and it is here that nutrients enter the bloodstream. The bloodstream circulates nourishment to every living cell in the body. But most nutrient-rich blood is first directed to the liver. Special X-ray machines and computers allow us to study internal organs like the liver as they carry out their work inside our bodies. The liver is a complex and important organ with dozens of jobs.
The liver is the largest organ, internal organ in the body, and it's the main chemical factory.
The liver also stores nutrients sent from the small intestine, providing a steady supply of nutrition to the bloodstream, even between meals.
The Washington Redskins.
The digestive system does not absorb everything we eat. Every nutrient that can be used for energy, growth, and repair will pass through the villi into the bloodstream. Some foods, especially fruits and vegetables, contain fiber. Fiber is not digested, but instead helps move food through your body. From the small intestine, remaining bits of food and digestive juices pass into a shorter, wider tube called the large intestine. In the large intestine, water is absorbed from food waste, which then gradually become more solid. These materials that the body cannot use, now called feces, are stored at the end of the large intestine until it's convenient to get rid of them. Liquids are vital for good health. In fact, you could live longer without food than without liquids. Many different foods are healthy to eat, as long as you don't eat too much of just one kind of food. A good diet has a variety of foods containing all the nutrients you need to be healthy and strong. Somehow, there's usually room for dessert.
I think you're gonna.
Our digestive system is essentially one long tube. It breaks down food and absorbs nutrients, fueling our bodies so we can come back for more.